Let us learn about interrupts. A computer program has only two ways to find the conditions that exist in internal and external circuits. One method uses the software instructions, which jump to subroutines on the states of flags and port pins. Second method is corresponds to the hardware signals called as interrupts that force the program to call a subroutine. Software techniques use the controller's time, whereas interrupts takes the controller time only when the action by the program is required. Interrupts may be generated by internal chip operations or provided by external sources. Any interrupt that can cause 8051 to perform hardware call to an interrupt handling subroutine that is located at a predetermined address in the program memory. All interrupt functions are under the control of the program. The programmer is able to control the bits in interrupt enable, interrupt priority, and timer control registers. Let us see the different types of interrupts available in 8051, which are automatically generated by internal operations. Timer flag interrupt TF0 and TF1. So this is raised whenever the timer overflows. It is reset when the resulting interrupt generates a program call to an appropriate timer subroutine which is stored in the memory. Serial port interrupt TI or RI. If the data byte received, the RI will be set in the SCON, and if data byte is successfully transmitted, then TI is equal to 1 in SCON. These are all together to a single interrupt. When the processor executes corresponding ISR, TI and RI are not cleared. Program used for serial data communication should reset TI and RI. External interrupts IE0 and IE1. INTR0 bar and INT1 bar 0, INT1 bar are used to set interrupt flags IE0 and IE1 in the TCON register. IE is equal to 1 when INTR bar is equal to 0 or a high to low is given on INTR bar. INTR bar is equal to 0 when IT is equal to 0. INT bar is equal to high to low transition when IT is equal to 1. IT is present in the timer control register. It is the programmer's duty to remove the signals at INT bar pin when the ISR is executed before the return I instruction. Now RATI instruction is an instruction to come out of an interrupt service routine. Now we have maskable and non-maskable interrupts. Maskable interrupts are the processor can delay in servicing such type of interrupts, whereas non-maskable interrupts are the interrupts which the processor or the controller has to service it at that instant of time itself. One example of a non-maskable interrupt is reset. It is an absolute command to jump to program address 0000H and start executing from there. When reset is equal to 1, the microcontroller is reset. After the reset is made low, these registers, that is the program counter, data pointer, A, B, program status register, timer control register, timer mode register, the timers, the serial control register will be holding 00H, whereas the stack pointer will be pointing to 07H. P0 to P3 will be having FFH, that is they will be behaving as input ports. SBUF might be having some random value. The interrupt priority register will be cleared. The interrupt enable register will be cleared, and the PCON register will also be cleared. Register bank 0 will be selected and RAM contents can be changed. The interrupt enable register holds the programmable bits that is used to enable and disable all the interrupts as a group, or if the group is enabled, individually also the interrupt source can be enabled or disabled. Bits in the interrupt enable register are set to 1 if corresponding interrupt source is to be enabled, or it is set to 0 to disable the interrupt source. Bit EA is a master or global bit that can enable or disable all the interrupts. Interrupt enable register is shown over here, the 8-bit register. Now this EA bit, if it is set to 1, all the interrupts are enabled. If this is 0, then all the interrupts are disabled. It is a global interrupt enable. The second bit is reserved. ET2 is reserved. ES is for serial interrupt. ET1 and ET0 are timer interrupts. EX1 and EX0 are external interrupts. The interrupt priority register bits may be set by the program to assign priorities for different interrupt sources so that important interrupts can be serviced first when interrupt occurs at the same time. The register IP is used to find if any interrupt is to have high or low priority. If the bit is set to 1, then that interrupt has a higher priority. If it is set to 0, it has the least priority. If two interrupts at the same time are arising, then the following order is used. That is IE0, external interrupt 0, timer interrupt flag 0, external interrupt 1, timer overflow flag interrupt 1, and then comes the serial interrupt. This is the timer interrupt priority register. PT2 is reserved. The priority for serial communication interrupt, priority for timer 1 and timer 0, priority for external interrupt 1 and external interrupt 0. So if it is 1, you're giving a higher priority. If you're giving a 0, then a lower priority is used. So every interrupt will make the program to do a hardware call, and a particular interrupt service routine will be executed. The routine will be stored at a particular address. So for external interrupts 0 and 1, the ISRs will be stored at 0003H and 0013H respectively. Timer interrupts TF0 and TF1 will be stored at 000BH and 001BH. Serial interrupt ISR will be stored at 0023H.